Okay, contour maps. So what we're going to do with this I broke this lesson down into 4 parts because usually it was one whole and we would work from it in sections anyway, but so this is part 1 of contour maps. So what we're going to do today is isolines and the contour maps. So what you need to know right now is you need to know what a field is. A field is any area of space with measurable quantities. So the room that you're in right now, that can be considered a field because you can measure the temperature by like the window, and then you could measure the temperature by your door and compare the two. Like if you were to go into a store like Walmart and you measured the temperature in the frozen food section versus the cat food section or the animal section. You can, any area with a measurable quantity that you can do temperature, you can do amount of light, you can do amount of sound, you can do, in this case it says atmosphere. So there's all different kinds of things, but a field is where you can measure stuff. You also need to understand that elevation is the meters or feet above sea level. Usually elevation has to do with land and how high land is up from sea level. So you need to know what a scalar field is, that a scalar field shows only magnitude. So in this map, it only shows temperature. It doesn't show the direction that it's moving in. It doesn't show anything. Sometimes when you show just atmospheric pressure, that can be a scalar field as well. But if you were to show magnitude and direction, so like what the temperature is and which direction that it's going in, that would be a vector field. So in this map, you can see that these little flags off of here, they kind of look like flags or sticks with sticks coming off of them. Those actually show the wind direction, and each one of these is a weather station. It's showing temperature and pressure and wind speed, all of that stuff. So these are vectors. It's showing magnitude and direction. So that's the difference between vector and scalar. Scalar is for magnitude. Vector is for magnitude and direction. So an isosurface is a surface or zone of equal value found in a field. So an isosurface can be an isoline, an isobar, anything like that, which we'll talk about in a minute. So isolines is what we're going to focus on. All of these isolines connect points of equal value. Okay, an isoline connects points of equal value. So if you had lots and lots of ones on a map, you would connect all those points of equal value, which would be ones. And I'll show you how to do that. Because what we do with these is we use them for topographic maps. You use contour lines to show the shape of Earth's surface. Some people, most of you have probably seen one of these. I use topographic maps sometimes when I go hiking to know which path I want to take, because sometimes I don't like to hike steep paths. I like to take ones that are more gradual. Sometimes it's a little bit longer, but in this map, I could show you that there are streams going down through here, which I can tell by the lines. I can tell you by looking at the lines that right here, it's much steeper. Right here, it's kind of like a cliff. Right through here, it's very gradual to walk through. And what else can I tell you with this map? I can see here's another river right here, or a stream right here. There's a stream right here. So I will teach you how to draw these lines and how to interpret these lines through the rest of these lessons. So what you do to create a field map is a lot of times you get measurements that are taken in all different areas of a field, and then you connect the points of equal value. So in this case, they took all of the 40s and they connected all of the 40s. Everything on the inside of the 40 line is greater than 40, and everything on the outside of the 40 line is less than 40, which you can't see anything less than 40 because they didn't measure anything less than 40. So there are 3 major rules. Rule number 1, the lines cannot cross each other. They can get close enough that they touch, but the lines will never crisscross each other. Okay, lines can never cross. They come close enough that they may touch, but they cannot cross over each other. Rule number 2, the lines are always curved. never are you going to have a line that makes, let me see if I can do a drawing tool. Here's my red. Never are you going to have a line that goes like this. That's a big no-no. Okay. And then rule number 3 is that the lines make circles. And if they can't make a circle, they will go off the map. And I'll show you that in our example. So here in my example, I'm going to go up by ones. Okay. So I'm going to start not at the smallest number. I'm going to go with a number that I see a couple examples of. So I'm going to go with 12. So 12 is right here. I'm going to put a little X there. I see a 12, and then I see a 12. We're going to pretend that my map is only this big. Okay. So if I go back to my drawing tool, I've got the right color. I'm going to start off the map here, and I'm going to make sure that my line goes straight through the middle of these numbers, and I go off the map. Because if I follow my rules, I have curved lines, and I make circles, or I go off the map. So in this case, I went off the map. So let's do 13s. There's a 13. I'm just going to do dots now. 13, 13, 13. Okay, I'm going to start to go off the map and go like this. Okay, now I only see a 14 here and a 14 here, but I know that 14 comes in between what two numbers? 13 and 15. So I know my 14 is going to go through here, and my 14 is going to end up going through here in this area. So I'm going to go through this way and around, whoop, and around that way. Does it matter that my line went and curved closer to the 15? Not a whole lot. Does it matter if it touches it? Yes, it should not touch it. Okay, so now I'm seeing all my 15, 15, 15, 15 is going to have to sneak through here, 15. So I'm going to do 15 and scoop around, and there we go. 16s. 16, 16, 16. Whoops, 16's got to sneak over here because there's a 16 right here. So let me go whoop, and curve down this way, and then go whoop. And then there's 17 and 18. There, I'm all done. Wait a minute. No, I'm not. I still have to pay attention to 11 and 10. Really, I should have gone through 10 a little bit better. There. So now I have drawn all the isolines that go up by 1. So my interval is 1. So if I write it in here, my interval, I'm going to make that a lot bigger so that you guys can see it, but you still have to highlight it. My interval is 1. Okay? Interval, not interval. Sorry. So that's my first example. So do isolines ever touch or cross each other? No. Okay. Do isolines usually have sharp edges or gentle curves? Gentle curves. And what do all points on an isoline have in common? They are all the same quantity. Good. And what two ways are isolines drawn? They're drawn either in circles or they go off the map. And is the interval from one isoline to the next the same for every line? Yes. If you go up by 1s, you go up by 1s. If you go up by 5s, you're going to keep going up by 5s. If you go up by 10s, you keep going up by 10s, so on and so forth. The last question says, does every isoline have one side where the numbers are high and the other side where the numbers are low? That's going to be key. So yes. So I want you to pause the video right now, and I want you to draw yourself a circle, not a circle, I'm sorry. I want you to draw yourself, I'm going to do it in red, a square for the edge of your map. And I want you to pause the video, and I want you to go up by 1s for your interval, and I want you to draw the lines. So pause the video now, And then when you come back, you can check what I did to finish it. Okay, to check your answers. So you go ahead and practice yours. Pause. And what I'm going to do is I'm going to 30, 30, 30. 30 is going to sneak through here. 30, 30, 30. 30 is going to go off the map. 30, and then we're going to come around this way. So let's start like this. And we'll go off the map. 31, 31, 31. Ooh, 31's going to sneak through here. 31, 31, 31's going to sneak through here. 31. Ooh, 31's got to go up and over 32. So let's, oops. I went too close. Go away. There we go. 31, 31, 31, 31, 31. Oh, there we go. Now, let's see if I can freehand 32. 32, 32, 32 sneaks in between here. 32, and then I got to make sure I curve. All right, 33. So the problem when you freehand sometimes is that you can mess up, but that's why there's this good tool. If we were in school, you'd be using a pencil. 34, and then 35 is just by itself because 35 is the highest point. There's nothing bigger than that, so 35 stays by itself. Then with 29, 29 is going to go off the map, and then you have 29. Because this is 26, you would have 28, 27, 26. Okay, so see, because we didn't have enough, we did not have enough numbers to go around, you had to go off the map. But see how 30, I could almost make it into a complete circle. 31, I could make into a complete circle. 32, 33, 34, and so on. Okay, so isolines connect points of equal elevation. The rules for drawing isolines. Rule number 1, the lines never cross. Rule number 2, they are curved lines, gentle curves. And rule number 3, they either make a circle or they go off the map. And then you've got some worksheets that we're going to do. There's a couple types of isolines that we're going to cover. You have isobars that connect points of equal pressure, because a barometer measures pressure. So isobars. Isotherms, because a thermometer measures temperature. That's going to connect points of equal temperature. Isotherms. And then you have contour lines. These are your isolines that have to do with equal elevation. So then what usually is going to happen, you're going to see a picture like this, and you're going to have to connect all the points of equal elevation, and then you're going to eventually get like a topographic map just like this. So can you draw isolines? Yes, you can. You know the rules. Isotherms measure equal areas of temperature. Isobars, equal areas of barometric pressure. And we will have practices on these that you're going to have to do them with Cami. And the Cami drawing tool, just like you watched me do, that will be super helpful.